How's it going? Thank you very much. It's my first time at Star Trek. I've heard a lot of great stuff, and honestly, exceeded all expectations. Before I start, can we take like one quick second to just appreciate the crew that puts this amazing conference together and has been putting this conference together for like over a decade. Thank you very much. Organizers, volunteers, AV people, everyone. So my talk is called Streams, Not Waterfalls. I'm just going to leave it there for now. Hi, I'm Dev, and I'm a dev. That is purely a coincidence. My name actually is Dev, and I just happen to be in software development. I recently joined Smart Data last week. A couple of my coworkers might be watching and hooting, so yeah, great place to work. These are some of my past projects/employments that I've worked at. I've been writing full-stack JavaScript applications for like 7 years or so. And I put these here because I just kind of wanted to set some context and background of what kind of experience that I carry with me and how they kind of inform my opinion. I'm also a content creator. I sometimes make YouTube videos and a lot of times ramble on Twitter about software development, architecture, programming languages, JavaScript, a lot. So if you like my talk today, you might also like some of my YouTube videos. So let me start with this. Single-page apps, I really like them. How many of you build single-page apps, something like React, Vue, Angular, whatever? Nice, a lot of people. How many of you enjoy building these apps? OK, almost the same amount of people. Cool. And the reason that I really enjoy building these kind of applications, because I really like the ceiling of user experience that we get by putting logic and state on the client side as close to the user as possible, where we can instantly interact, instantly respond to whatever the user is doing, give them instant feedback. And even if we are doing some stuff in the background, something that requires a network, we can still give them immediate feedback about what's happening so that they don't have to be confused. This is one of the superpowers of single-page applications that we unlocked once kind of client-side routing and client-side rendering got popular and got feasible. So what does the experience of using some of these apps look like for the user? Again, it allowed web developers to get very close to native applications. So it should feel like it so, right? Let's see. So the user hits your application, whatever, using the browser. They put in the URL, and the browser loads an HTML document. And then it loads some JavaScript and keeps loading some JavaScript for a long time until you're actually ready to show the app. Luckily, this is not how we do things anymore, because we discovered things like dynamic imports and smarter bundles that can do code splitting very smartly, which allowed us to do something like this, where instead of loading a huge chunk of JavaScript at the very beginning of the load, you just load a small initial chunk of code, which then tells your browser or tells your application what else you need to load for the current page that you're on. So now, we have a much better time loading the application. I have removed the document that you might have seen here, because it's pretty obvious it's always going to be there. So for simplicity's sake, you're not going to see this document in these future graphs. But now we load some JavaScript. And that JavaScript has some information about other bundles. And we load whatever bundle we need for the current route, because that's all the code we need. And that's it. OK, now that we have code, what does the application do? It needs to show some data, which means it needs to fetch some data. And the second kind of superpower or catalyst that kickstarted the single-page application, fully client-rendered experiences was AJAX, or the ability for this JavaScript code to reach back to the server on its own, get some data, and do some work without causing a full-page reload. My friend Chris Nelson just went into a pretty good history of web development. So if you weren't able to check his talk, you can probably catch that on YouTube later. But again, the point is, Ajax was very helpful to allow us to build these powerful experiences. And you might have known, or you might have even been around when Google Maps or Gmail they first started using these kind of technologies for their incredibly dynamic experiences. But it could be a foot gun sometimes, and I'll get into that soon. Also, I'm kind of experimenting with DALL-E and AI-generated images, so if sometimes you see way too many fingers or too few fingers, blame AI for that. Yeah, Spinageddon. I want to give you guys like a tiny challenge tomorrow, or pick any day. And throughout the day, every time you use an application, especially if it's a web application, just take a mental note of how long or how much time you spend just looking at spinners, just sitting there and waiting for something to load. Just try to make a small mental note of how much time you spend looking at loading spinners using normal web applications that you do in your daily routine. And then try that with the applications that you are building and see if you kind of like cross that average bar, or if you're making the experience worse, or if you're making that experience better for your own users. But this is essentially the problem that we ran into by kind of overusing Ajax for everything. We already used Ajax here for fetching JavaScript, but now we also use it to fetch data. So this is kind of the issue that we run into. Once we split our JavaScript bundles apart, we still need to fetch data. And the only way we know what data to fetch is if we have the actual code that we need to render the UI. If we don't have this code, we can't really fetch the data, right? Because we don't know how to. And once we have this data, we might need to go and fetch more data. So this is how we keep running into this waterfall problems. First, our JavaScript bundles were too big, so we broke them down. But as soon as we broke them down, we now have to make 2 trips to the server to get all the code that we need for the current page. Then we start executing that code, and then we start fetching the data. So now we already are at 3 round trips. And once this data is fetched, we start rendering some UI. We hit a component downstream or further down the tree. And maybe that component, again, fetches some data, which means we have this waterfall again. And this might keep happening over and over again. You might end up rendering a component here that you have code split that for some reason you are lazy loading. If you have too many components on the same page, if you have a few thousand components, sometimes you can't even fetch all those components in the same bundle, because sometimes your data dictates what component gets rendered. So you keep running into this waterfall issue. And how does that affect page loads? Exactly like that. You keep looking at loading spinners until the stuff that you need to see has been loaded. But the reason we ran into this problem in the first place, even with client-side JavaScript and the ability to fetch stuff as we needed, was because composability, because we really like having composable solutions. We really like building components. The component model pretty much won the front-end framework or the front-end methodologies, whatever you want to call it. We tried MVC for a bit, didn't quite work, but now every framework has components. And turns out the composability is really nice. Now, what do I mean by composability? In this context, in the scope of this talk, when I'm talking about composability, I'm specifically talking about the ability to co-locate our server data dependency with the UI that is going to show that data to the user. In this case, you can see that we have a component. I'm using the example of React, but this will probably look very similar in Vue, Angular, whatever you're using. The point is that in this component, we say that this is the function that we're using to fetch the data from the server. We just use a hook here. Again, different frameworks have different versions of this. You can imagine this to be something like React Query, TanStack Query, or maybe your own internal version of use async. Please just use TanStack Query. So you get the data out of it, and then you just render it to the to the DOM, to the HTML, whatever you're using. And this comes with some really nice benefits. This is flexible, of course. You can fetch however you want. You can render it however you want. It's composable, which means this component works the exact same way, regardless of where I put it. I don't need to wire up any additional things to make sure that this component works properly. That's it. This is a scalable approach. Scalable, I don't mean, by scalable, I mean the amount of complexity of components or code or developers in your team. Because if you have a few hundred, a few thousand components, it can get really difficult to keep track of what component needs what data on what page and how it's getting there. If every component is just allowed to fetch its own data, then you don't have to think about it from the outside. You just put those components together and you're done. It allows locality of thinking. So when I'm working on this component, I'm only thinking about the code inside this component. I don't have to worry about how the rest of the world is structured, because everything that I need is inside the component. And once I'm outside the component, I don't have to think about how this component operates. It's all nicely encapsulated. And of course, it's really, really type safe. We don't have to do anything extra to give TypeScript the hint of what this data is going to be. But obviously, it's a foot gun, like we talked about. If you don't know what data a component needs until you have the code for that component, you now need to wait for that code, which means now if you're code splitting everything, you're now blocked to fetch that data until you can fetch that code itself. And even once you have the code, you now need to wait for that code to start executing, which means if a parent component somehow blocks it, or maybe the parent component is fetching its own data and it's not showing anything inside, it's just showing a loading spinner, any components that inside that need to fetch their own data, they're just blocked. You're just waiting there, and you end up back in that position where you fetch some code, then you fetch some data, wait for it, then again you fetch some data and you wait for it, and you just keep building up that waterfalls. And as a user, this is not a great experience. You can look at something like the core Web Vital report that Google comes out with that talks about these performance issues and page load issues. One of the 3 core Web Vitals is largest contentful paint, which basically means how long did it take for your site or for your page to get the largest amount of content that it needs to show to the user. And if that's under 2.5 seconds, you're in a pretty good shape. But again, you can try your application out. You can use it in a real environment that real users might experience. And you can check for yourself how long it takes. And you can imagine this being a big issue for any businesses that rely on really fast page load speeds. Anything that's like an e-commerce or content sites or marketing sites, those need to load fast. So I have a demo for that here. Cool. This is a simple e-com demo. I'm going to zoom out a bit. So you can see what's happening here. I can go back. If I can click here, you see we are loading this, and then we're loading this. Now, there are some exaggerated, artificially introduced waterfalls in here, just because this is such a simple demo that I couldn't really get it to naturally get into waterfalls. But in any application with real complexity, you're inevitably going to get into this waterfall situation. So I can go back, and you can see this again. We see these 2 loading skeletons, and then we see this one. This is, in my opinion, not a great load time. And even though this is just a dummy API, if you're hitting a real server, the server might be doing a lot of work. It might be going to a search engine or your internal whatever searching database you're using, and it might have to query that. That could take a while. And there's a bunch of different queries going on at the same time. And the waterfall is really not helping the user experience. I can click this, and you can see the same thing. We see the loading spinner first, because first we need to load the code. Then we fetch that data. And then we have this, the UI. I can even do this. Let's go to the network so that we can throttle. And now if I click on this, you can see we were waiting for the code. Actually, need to refresh. Just got rid of that. There we go. We're waiting for the code. Then we start loading the data. I can go here too. We're waiting for the code. We got it. And now we start fetching the data. We don't see the data here because it's not a real network call. It's just like a timeout. But you can see how every time the fetching of data is blocked by loading the component itself. Quick side note. Browsers have storage. How many of you knew or know that browsers have storage, like local storage, IndexedDB, session storage? Nice. Almost everyone. How many of you use it in your apps? OK, somewhat smaller number. If you have some data that the user interacts with very frequently or regularly, just do them like a solid and just cache it on the device so that they always have access to it, even if it's just read access. And you can very quickly interact with it and then synchronize it with the backend. Check out Replicache. That's all I'll say on this topic. I just have to bring it up because every time or someone brings up front-end performance, these offline first and local first people show up. OK, so composability is nice, but it's hurting the page load performance. So I guess I'll just hoist it. Routing libraries have had the capability to give you the ability to hoist that data fetching up outside of your components for about a decade now. Ember Router had it a while ago. React Router had it up until version 3. But then version 4, they kind of gave up on that. And they're like, yeah, we like composability a lot more. Just you're fine doing Waterfalls. Just keep doing those. They walked that decision back a couple years ago. But the point is, you can see we have now taken that fetch my data function and pulled it out into a separate function. And inside my component, I either get that data through a hook, which means it's probably in context, or I get it passed down as props, which is what Next.js does. So you'll see this pattern in Next.js, React Router, Remix, SvelteKit, Nuxt, I think. I don't know. I haven't really used Nuxt. But you'll see this pattern, because what this allows you to do is the routing library can call this loader function directly without having to go through your component, which is a little brittle, in my opinion. It's kind of the opposite of composable, obviously, because now you have these two functions that actually kind of have to work together, but they have to be wired up to the router correctly for them to work properly, which means now you have to track that throughout your application. This is actually, when I say brittle, I mean a little more difficult to refactor and change, which, again, the thing that I liked about composability. Imagine inside this page, you now add a new component, which needs some new data. And now you have to make sure that you go up to the loader, the correct loader, you add that new data fetching function in, and you make sure the new component gets that data. Cool. OK, sounds easy enough. But what if there already is an existing query for some similar data? You can just reuse it. But maybe that existing query doesn't get all the fields that you need. Maybe it only has a subset of fields, which means you can either modify that query and get all the fields and risk breaking something else in your application because it wasn't expecting those extra fields to be there. Or you can just put a new query for all the fields that you need, and you end up duplicating a little bit of work. This gets worse when you try to remove a component that was depending on some data. Because now, OK, you remove that component, and you go up to the loader. Can you remove that data fetching function from the loader for the component? Because, yeah, you can just remove it. You just get rid of the component. But are you sure that no other components are using that data? You have to now make sure you go through your route tree, all your components. You have to find the components that are using that data. And if you find any, you cannot remove them. So this can get a little brittle because we don't have that direct connection between the data dependency and the UI anymore. And you're probably going to break a bunch of things in production if you are not careful with this pattern. That said, it actually fixes a lot of our waterfall problems. So this is what initial load might look like. You load that initial JavaScript bundle that has all your route definitions. But once you have that, you can just parallel fetch everything that you need, because your router is fully aware of what components it needs to load and what data it needs to fetch. And every time you client-side navigate, you only come back here, and you repeat this process. You load some JavaScript, you load some data, and everything happens in parallel. This is pretty fantastic for performance with single-page applications, both for initial loads and for client navigations. But it cost us that composability. Let's look at a quick demo for that as well. And I forgot to show the code last time. But let's see what it looks like first. I'm going to refresh, and I'm going to go to host state fetching. Now, I'm using a feature here called React Transitions. And what it does is, it's not too important for the demo. The idea is that it waits for all the data to load. And only when the data is loaded, it shows the UI. So again, I kind of eliminated loading spinners because of that. I can bring them back. But that's the only reason you're seeing the URL change, but the UI doesn't change immediately. Other than that, the performance of this seems much better. The page loaded much more quickly than the client page. And by page, I mean all the data, not just an empty page with spinners. And same thing here. I click on this, and I'm on this page. Count. I click on this, and I'm on this page. I can keep going back. And I can even introduce some network latency. There it is. So now I'll go back. And if I go to hosted fetching, it takes a while. And now it's here. Oh, that was with fast 3G. OK. Let's go back then. This will be a real test of speed. No, I think that's the same. OK, let me quickly go over the code for both of these. So this was the client version. This is our component. We have our divs with Tailwind. If you don't like Tailwind, please close your eyes. So I'm rendering this featured product section here, which is going to get its own data. Client get featured product data. If it doesn't exist, we show the skeleton. If it does, then we show the featured product. And then we show trending products, which is going to fetch its own data, show some skeleton. And then once the data is available, it's going to show those products. It's exact same thing for you. It's a very simple demo. But you can see that we have the data dependencies and the UI nicely co-located in the same component. And that's what makes this composable, because I can render this component anywhere I want and not have to worry about anything else, and it'll just work. Now let's go to the hosted version. So the hosted version, I'm going to get rid of that. It might look something like this. It actually doesn't. I'm going to get rid of that. So it's probably going to look something like this. We have this, I don't know, this was from an older demo. You can define a loader function. In Next.js, this would be get server-side props. But in this version, like we are pretending we don't have a server, so we're doing everything from the client. So this is the function that will make these 3 API requests to our server, get all that data at the same time, and then return it here. And then inside our page, we can use something like use loader data, or maybe we get it from props, we get it from context somehow, and all the 3 pieces are going to be here. And we can pass them down into whatever components are needed. But now you can see that I can't really reuse any of these components at all anymore. They're all coupled to be in this route. Or basically, the parent always has to make sure that their loaders are fetching the data that are required for these components. But for that cost, we get pretty good load performance. Cool. Another quick side note, GraphQL. GraphQL has this really nice library called Relay, which was developed at Facebook/Meta. What Relay does is it does this process of hoisting on its own. It's basically a compiler. And what you can do is you can put your GraphQL query fragments directly inside your components. So fully co-locate them, just like we talked about. And the Relay compiler will traverse your component tree. It'll pull out all the query fragments and put them in one large query that gets executed at any routing events. And this gives you kind of the best of both worlds. This gives you full composability, but also gives you full performance because it hoists everything out. So if you're using GraphQL, now if you're not using GraphQL already, this is not the reason to move to GraphQL. GraphQL has a lot of cost. It's very hard to get right. So again, if you already have GraphQL, or if you're considering moving to GraphQL, know that there's tools like Relay that are really great at solving this waterfall problem and improving your performance. But for the rest of us muggles, maybe SSR will help, right? Let's render everything on the server. Let's run a JavaScript server. Let's render our whole application when we get a request. And let's just return plain HTML. Probably marketing people said something like this, and then we all believe them. No, but it does actually kind of help, the initial load. The thing is, now the server is doing a bit more work. The server is responsible for fetching that data. The benefit with that is the server is ideally much closer to your database, which means if a client-to-server connection could take like 100, 200 milliseconds, the server-to-database is going to take much less time than that. It might only take 10 to 20 to 30 milliseconds. It's an order of magnitude smaller than your client-server waterfalls, which means you're ideally going to get much better initial load if you just let the server fetch all the data and serialize it with the initial document. So you can see this yellow line. This yellow line is actually now your new largest contentful paint, which means you've pulled back one of the important core web vitals from there to here, which is pretty good for your initial loads again. And the other benefit of rendering on the server is now you know exactly what JavaScript or what components need to be downloaded by the client. So you can get all of them in a single bundle, in a single fetch, and you never load the components that you don't actually need to render, which was a problem with this plain code splitting, because you might be fetching 500 components but rendering only 100. This is not a problem with SSR. That said, once you load the JavaScript, once your client-side application starts running, and you do client-side navigations, you lose all those benefits. And now you're back to waterfall land, unless you do that manual hoisting. So this is kind of a quick recap of everything we talked about. There's the classic SPA with a little bit of code splitting, which gives us that full composability, but is bad at initial loads and bad at navigations because you're probably doing a lot of waterfalls. You can add hoisting, and for the cost of composability, you increase your performance. You can also use SSR for your initial load. And you can combine both to get kind of the optimal performance. This is what framework like Next.js, Remix, SwellKit, anything that calls itself a meta framework or someone calls it a meta framework, this is what they offer you. They give you a place to hoist your asynchronous stuff like data fetching, which allows you to really improve performance. But because there's an additional system that you now have to deal with, you lose that composability that you get with pure components. So how do we solve this problem? Let's talk about streaming. Before we get into streaming, though, the other thing I wanted to mention is and by we, I mean we SPA developers, single-page app developers, we are not the first ones to kind of reach this problem where we need to improve the performance of our code somehow, but we are losing out on composability. We have two different systems that we have to deal with. We have some stuff that deals with server state, and we have some stuff that deals with client state, and those two don't really compose well with each other. And while we can achieve performance by making the separation, we don't really have, our developers are kind of suffering for it. So let's talk about streaming. We talked about waterfalls a bunch. So streaming, it has existed in some form like for maybe 2 decades. And it's this really nice and kind of primitive capability of HTTP where instead of doing a bunch of work and then sending one response to the client, on the server, you can just send a response, and keep doing your work, and then keep adding things, keep adding more data to that same response as you're doing more work. And at some point, you can say, OK, I'm done. Here's that, that was it. And throughout that process, your client can keep receiving this data and keep doing its own work. So you can really use streaming to very efficiently parallelize work between your client and your server. Because your server can just keep sending data as it's available, and your client can keep getting that data and keep doing its own work as it's needed. So what can we do with streaming? Let's talk about kind of maybe an ideal world where we would like to be as SPA developers. Here you can see that as soon as we now pulled back our initial kind of fetching even more. As soon as we have this piece of data, we can send a response to the client immediately, and the client can now start loading all the JavaScript that it needs, any assets that it needs, like CSS, font files, images, whatever else. And at the same time, the server is still doing more work. The server is still going to database or computing whatever it needs to do. And once it's done, it sends the final data, say, OK, here's the data that I just fetched, and I'm done now. This green line needs to be up here. I forgot to update that. Sorry about that. But imagine this green line is right here. So what you can see here is we have pulled the initial document fetch and assets fetch much further back into the timeline, which means this orange point could very well be our largest contentful paint, because that's where we get a chunk of data. We have the data already. We can even just render it on the server and send back a rendered piece of UI that has this data but doesn't have this data. And while this data is fetching, our browser is doing a bunch of work, loading a bunch of stuff, JavaScript, whatever it needs, and it starts up the single-page application. At the same time, your server is still fetching data. You can even take this orange line and pull it all the way back to the origin, which means as soon as your server receives a request, you can immediately send like an empty HTML document with some of the JavaScript that's needed. And by doing that, you have a much better parallelization between the client and server. But in this case, you can see that here we're waiting for this data. We're blocking at this data because maybe the first time the user sees anything, we want them to see this data. We don't want them to see an empty page. Maybe we don't want to show them a bunch of loading spinners. So maybe we can block on some data. But we can choose what data we want to block for and what data we want to not block for. We can just keep doing that while the client is doing its own thing. So this is what we can do with streaming UI. But how do we do that? A big problem with HTTP streaming, like I said, it's almost a very primitive technology. What you can do with streaming is you send back an initial kind of response, and whatever you send after it, it gets appended right under it. And then the next one gets appended right under it, and right under it. So basically, when you're streaming some data, you're creating a sequence. You have to stream that data in sequence. And this is problematic with HTML because we don't necessarily or think about our UIs in that sequence format. The very first thing in our UI or the second thing in our UI can take a bunch of time to load, which means all the rest of our UI is now blocked by this one thing. So this kind of sequential streaming doesn't really apply to HTML directly that well. So this was kind of a challenge for a while when we were, when web developers were trying to figure out how to apply streaming to increase the performance. Finally, some MPA frameworks figured it out. I'm going to show an example real quick. But here's kind of at least my idea of what it did. So you have the initial kind of multi-page app model. I've given them both threes here as an average because, again, you have to do a bunch of work on the server, and then you send an HTML response. So a lot of times, combine that with the full page reload, the user can spend a lot of time just looking at a blank page or a blank loading spinner if the server is doing a bunch of work. But once you are able to do streaming on top of it, You can start sending UI immediately as it becomes available on your server and not have to block on anything. Same thing with navigation. Obviously, you don't have interactivity because all your state lives on the server. You're probably not using a bunch of JavaScript. You don't have instant interactions. But you can add that by using islands. So islands would be something like putting a mini React or Vue application inside your Rails application or inside your whatever static site. Or maybe you would be using something new that Rails or Phoenix or something that has like live view. But they, again, break a little bit of your composability because you have server state, and now you have client state. And you can pull all the client state into the server with something like live view. But then, again, you lose the interactivity. So we always end up at this situation where we have pretty good performance, but somehow our solution is difficult to work with. It's probably difficult to use as well. And a quick example of that, I'm going to pull up Marco. So Marco is a multi-page app framework that was developed within eBay. It's being used by eBay.com. And this is kind of like the de facto example of really, really performant JavaScript frameworks. You can see here that they have Marco is a really advanced compiler. It has an awkward syntax, so don't think about that too much. I'm just trying to show this here. What this does is, now, Marco is a server framework. All of this code runs on the server, not on the client. So on the server, we create this promise, and we use the await tag to define that we are waiting on this promise. And while the promise is still pending, we are going to render this placeholder, and we are going to stream it down, and that's what we're going to show, or that's what the browser is going to show. Then as soon as person resolves, we render this UI, and we, again, send it in that stream. And then there's a bit of client-side JavaScript that can identify exactly which await tag needs to be updated with this new UI. So even though in your HTML response, you'll have your entire first HTML with your placeholders, and then at the bottom, you'll have just a little piece that says, hello, your name. And it'll have some special properties, and there'll be some little bit of JavaScript that knows exactly where to put it. This is called out-of-order streaming. This is something that Marco really pioneered. And the idea is that on the server, you just do a bunch of work. You have whatever promises, whatever asynchronous actions that you have. And you can render placeholders, and you can just stream that UI as the initial UI for your application. And as your asynchronous function starts resolving, as they start getting data, you can just keep streaming whatever data you have available, the UI for that. And the client can just keep picking that up and keep putting that at the correct places in the UI. So you are not kind of blocked by the sequential nature of web streams. But again, you can keep doing that. But now, as soon as you try to add interactivity on top of it, you lose a little bit in your composability because you have two different systems to deal with. Let's talk about streaming data. I talked about frameworks like Remix and SvelteKit and Next.js. A lot of them have actually added the ability to stream data. And you can see that it actually massively helps with performance to give you that last squeeze of client-server parallelization. So let's see a quick example of that. I'm not using one of these frameworks, so my example is not actually going to work. But I can just show a quick what it looks like in terms of syntax at least. So here's our component. We are, again, using, where is my loader? Oh, in here. OK, so here's my component. You can see I have the OK-ish ecom demo instead of the bad ecom demo this time. I still have my loader here. This time, since we are using the Remix syntax, this loader actually runs on the server. So frameworks like Remix and Next.js give you one additional advantage where your hosted data function can run just on the server. So instead of you having to make 3 separate API requests from your client to the server, you just make one request from the client to server, and the client can make 3 different requests to your database or to whatever external APIs that you might be using, which will, again, also slightly help with reducing the amount of work that your server has to do. And here, again, because I am not actually using Remix, I got a little lazy. I'll fix that next time. I would be using probably something like use loader data to get that data and pass it into my components. But right now, this function is going to wait for all 3 pieces of data to come back before it renders the UI or it renders the home page. I can change that by just getting rid of this promise.all. And now, this function is not going to wait for any of them. The function will run. It will start all 3 of those fetches, and then it'll start rendering my component. And if it's server-side rendering, it will render them with the placeholders, stream it to the UI, stream it to the client. And as the data starts coming in, it'll start streaming just that data. And I can change that with just an await here. Now this function is going to wait, but just for the trending data. It's not going to wait for anything else. And the for you data and the featured product data are going to get streamed to the client. And on your client, you have a way to specify if you want to show a loading spinner here or not. I'm going to talk more about that. I don't want to talk too much about Remix today, because I have more important things. But frameworks like Remix, SvelteKit also allows this, where you can, instead of awaiting a promise, you just pass down a promise. I believe Remix, you also have to wrap in something like deferred, like that. So this is probably like some sort of syntax that you have to apply to tell Remix that, hey, I'm streaming some data, go into streaming mode. I think in SvelteKit, you don't have to use deferred, but the idea is the same. OK, so we took streaming. We tried to apply it to both the SPA model and the MPA model. On the MPA model, we can use this, this idea of async fragments like Marco, where I can just await some date, or I can declare that I'm waiting for this data, render some placeholder, or stream the final UI. Or on the SPA side, I can use my hoisted out data fetching to declare that I want to wait for this specific data, but I don't want to wait for others. Is that really the best we can do? I don't think we fixed our composability problem. We still have to deal with 2 different systems. I've also added a few other metrics or comparison points here. You can see that because when you're doing MPAs, when you're doing all the work on the server, and you only have a little bit of JavaScript on the client for some interactive bits, your bundle sizes are much better, and your hydration is much better. While in this case, you have to load the entire page, and you have to hydrate the entire page. But for that, you get interactivity, because you have full client-side navigation. Here, you don't have that, because it's still doing a full page reload every time you go to a different page. Which time do we have? Cool. So I don't know if I'm fully satisfied with this. And I'm happy that the React team thought the same thing, because they built React Server components. And that's my, quick intro to, or I guess maybe pitch for why I like server components especially. Architecturally, they kind of blend the best of both worlds for an MPA and an SPA. You can see that we have, with server components, we have the bundle size and hydration of an MPA island setup, because we are not sending all that JavaScript to the client. We're only sending the interactive bits, the ones that have some client-side state. But we also have the interactivity of a regular SPA, because we don't have full page reloads. When we go to the next page, it's a client-side navigation, even though we are using server components. We also have the initial load and navigation metrics that we get with streaming, because server components make streaming really easy. I'm going to show a quick demo of that. And finally, server components, again, that's the server part. You still have the client part, your regular React components with client-side state and your hooks. Those 2 actually compose really well together. And that's kind of the whole point of how server components are able to fix a lot of these problems that we already have fixed in other setups, but they bring back the composability that we really wanted out of the initial solutions, and that we kind of gave up in pursuit of performance. Final demo. All right. Before the demo, how many of you have heard of server components, React server components? OK, not a lot. Cool. So this will be a cool intro. Let's. actually go to this demo first. I'm going to go back, and I'm going to click on server component fetching. You're going to see that it's very similar to our hoisted fetching, and we are using React transitions as well, which means the URL changes, we wait for all the data to be loaded on the server, and once it is, we render the entire page, and we send it to the client. I can click on this, and you'll see the same thing. I can go to account, exact same thing. And this is pretty fast. Do I still have, no throttling, OK. I've also artificially introduced some slowdowns for any data fetching. So you might be noticing that. Let's see what the code looks like for this. I'm going to go to server index. And I'm using a framework called Vacu, which is a very minimal React server component framework. If you're building something for production, I would recommend Next.js. That's kind of the de facto choice for server components. But here, for the demo purposes, I'm using Vacu. I'll explain the suspense boundaries in a second. But here, we are rendering our featured product and our For You products. And inside featured product, you can see that we're just calling our server API. And here, again, we're just calling our API inside our component. So we have all the nice composability that I talked about earlier, where here's my component, here's my data that I'm fetching, and here's where I'm rendering it. That's it. Everything is encapsulated inside this one component. Same thing here. So this looks very similar to the use query or composability with the client components that was causing all the problems. This still looks like it, but it doesn't have a lot of those problems because everything happens on the server. The more important thing that we probably need to understand about server components is that they only run on the server. This code is never shipped to the client. It's never run in your browser. It's never executed there. So while this is called a React server component, you actually think about it a lot more like an EJS template or a template on your server that you might plug into your server framework like Express or Ruby or Phoenix or Django, whatever. And I can even show this by, in the console, you can see all of these console logs, which I have put in these components here. You can see console log feature product, console log feature product. And this is not just SSR. If I go here, if I open the console and I refresh, if it refreshes, there we go. I won't see any of those console logs. I don't see featured product. I don't see trending. I don't see For You, because all of those only show up in my console, because these components run on the server. OK, but what about streaming, though? Let's talk about streaming. So here, the featured product component is an async component. We are using regular old async await to fetch data from our database or from whatever we are using, because we are just running JavaScript, and these only run on the server, so we can do regular async await. What this also allows us to do is this suspense. So I'm just going to wrap this featured product component with a suspense boundary, and I'm going to give it a fallback. Let's save this, and let's go back. And you can almost instantly see what happens. But I'll go back. I'll click this again. And you can see we wait. But now we don't wait for this data. As soon as the product data is available, we immediately render the whole component or render the whole page and stream it down to the browser. And for this, because it's not ready yet, we are going to render the skeleton. And as soon as it is ready, everything inside it, we just stream down that UI. So the client never makes more than one request to the server for the data. The client only goes to a server and says, give me this page. And the server says, OK, here's your HTML, here's your UI with a placeholder. That's it. And after a certain point, it keeps the stream open. And once all the data is ready, it sends down that additional piece of HTML. I can even wrap this in a suspense like that. Save it. And now you can see both of these are loading skeletons. As soon as I get this data, it gets streamed in. As soon as I have this data, it gets streamed in. No more waterfalls. You might also see that we don't see a skeleton for this, because actually these three components in here, where is it? If I go inside feature product, you can see inside featured product, I'm calling trending products, which is also an async component, but it doesn't have its own suspense boundary. If I can bring that back, I basically have the original experience back, where all three of them have their own skeletons, but there's no waterfalls. The server does all the work, and it keeps streaming down as it has the data. So we don't have this nasty problem of client-server waterfalls. And because the server is much closer to your database, that's where your data is, you can render all of these much more quickly than if you just had your client-server waterfalls, and you still have all the composability that you want. Now, obviously, you probably don't want to put a suspense around every async component. So I'm going to remove this from here. Let's say that I remove that and that. Let's just get rid of all the suspense boundaries. And maybe we just want one suspense boundary on the top. And we don't want to show stuff in between. We don't want to deal with spinners or skeletons. We're just going to wait for this to show up. And OK, here you see loading products, and then we see the whole thing at the same time. I can go back. I click this again. We just see loading products, and all the UI just shows up at the same time. The other reason why this is really, really cool, at least to me, is we don't have the data that defines our streaming boundaries or how we stream from the server to the client. It's the UI, which means we can apply UI consistency here. For example, let's say as a product designer or as a UI designer, I like this page fully populated. I don't want loading skeletons in between. For example, if I put a suspense around this, and for fun, let's go in here. Let's go to our feature product. Let's go to this. And I have a timeout here. I'm just going to multiply it by 3. And let's say that I'm going to refresh. Why do I still see loading products? Oh, I didn't save this file. OK, refresh. Maybe I don't, as a designer, I don't like this. I don't like that the UI appears to be an inconsistent state where I have some data, but there's still loading skeletons here. That's fine. I can just remove this suspense and just add a top-level suspense. Or I can just have no suspense at all, which means everything's going to happen in the background. The user still sees the original page that they were on. While everything happens in the background, everything gets streamed in, and the final UI is constructed. But here, I can simply say that I want a top-level suspense. I don't want any of my UI in inconsistent state. And all of that appears at the same time. This kind of plays into the second core web vital, which is called cumulative layout shift. I know it's CLS. I don't fully remember what it stands for, but it talks about shifting in your layout. Because if you have too many things streaming in at different times, you might have the layout shift at different times as well, unless you are really, really good at accommodating for that. So sometimes you might just want to look at your UI and say that, I don't want this specific component to enter a loading state because it's next to this component and whatever. These are things that you cannot really do on the data level. This is something you could do with something like Marco, because you had the similar idea of asynchronous components or asynchronous UI. And this is something you can do with server components. Again, while still retaining full composability with your UI and your data. And that's why I gave it this kind of score. I think it kind of gives us the best of both worlds, both in terms of the performance, the bundle size, the hydration, the interactivity for the user, and the composability for us developers. That's all I have. Thank you very much for listening, and I'll take questions. Any questions? That looks like a no. All right, thank you. This was the last talk. Hope everyone has a great day or good evening, I guess. Thank you very much.